Anchoring switchboard assemblies to channel iron sills offers several benefits over reinforced concrete housekeeping bases. Firstly, increased flexibility is provided. Channel iron sills allow for easy adjustment and relocation of the switchboard assembly. This flexibility is beneficial during building renovations or equipment upgrades, allowing for quick and seamless changes to the electrical distribution system. Secondly, floor load is reduced. Reinforced concrete bases can add significant weight to the floor load, especially in multi-story buildings. Channel iron sills are relatively lightweight, reducing the overall load on the supporting structure. Thirdly, access to connections is improved. Channel irons elevate the switchboard assembly off the floor, providing better access to cables, terminals, and other electrical connections. This enhances maintenance and troubleshooting operations. Fourthly, vibration transmission is reduced. Concrete bases can transmit vibrations from motors and other equipment to the switchboard assembly. Channel irons act as an isolator, reducing vibration transmission and protecting the electrical components. Fifthly, easier grounding is achieved. Channel irons provide a convenient grounding path for the switchboard assembly, as they can be directly bonded to the building's grounding system. Sixthly, resistance to corrosion is increased. Channel irons are typically galvanized or coated for corrosion resistance, making them suitable for use in harsh environments or areas with high humidity. Seventhly, compatibility with existing infrastructures is enhanced. Channel iron sills can be easily integrated with existing building structures, such as steel beams or concrete slabs, allowing for retrofitting of electrical systems. Eighthly, it can offer cost-effectiveness. In some cases, anchoring switchboards to channel iron sills may be more cost-effective than constructing reinforced concrete housekeeping bases. Overall, anchoring switchboard assemblies to channel iron sills offers greater flexibility, reduces floor load, improves access, provides better vibration isolation, facilitates grounding, resists corrosion, enhances compatibility, and may offer cost savings compared to traditional concrete bases. When considering the specific requirements of an electrical installation, it's important to evaluate these benefits in relation to factors like site conditions, load requirements, budget constraints, and long-term maintenance considerations. For example, the flexibility offered by channel iron sills is particularly valuable in environments where future modifications or expansions are anticipated. This can save time and money in the long run by simplifying the process of relocating or reconfiguring the switchboard. The reduced floor load is especially significant in older buildings or structures with limited load-bearing capacity. In these cases, using channel iron sills can prevent structural problems and ensure the safe installation of the switchboard. The improved access to connections provided by channel iron sills can streamline maintenance and troubleshooting activities, reducing downtime and improving the overall efficiency of the electrical system. This is particularly important in critical applications where uninterrupted power supply is essential. The vibration isolation provided by channel iron sills can protect sensitive electrical components from damage, extending their lifespan and improving the reliability of the switchboard. This is especially important in industrial environments where heavy machinery and equipment generate significant vibrations. The ease of grounding offered by channel iron sills can simplify the installation process and ensure compliance with electrical safety codes. This is crucial for protecting personnel and equipment from electrical hazards. The corrosion resistance of channel iron sills makes them suitable for use in harsh environments where concrete bases may be susceptible to deterioration. This can extend the lifespan of the switchboard and reduce the need for costly repairs or replacements. The compatibility of channel iron sills with existing building structures makes them a versatile option for retrofitting electrical systems in older buildings. This can save time and money compared to constructing new concrete bases. The potential cost savings associated with channel iron sills can make them an attractive option for projects with budget constraints. However, it's important to carefully evaluate all costs, including materials, labor, and installation, to ensure that channel iron sills are indeed the most cost-effective solution. In addition to these benefits, channel iron sills can also improve the aesthetics of the electrical installation. By elevating the switchboard off the floor, they can create a cleaner and more organized appearance. This is particularly important in commercial and institutional settings where aesthetics are a concern. When selecting channel iron sills, it's important to choose a material that is strong enough to support the weight of the switchboard and withstand the forces of vibration and impact. Channel iron should also be properly galvanized or coated to prevent corrosion. It's also important to ensure that the channel iron sills are properly installed and anchored to the floor. This will prevent the switchboard from shifting or tilting, which could damage the equipment or create a safety hazard. In summary, anchoring switchboard assemblies to channel iron sills offers a range of benefits over traditional concrete bases. These benefits include increased flexibility, reduced floor load, improved access, better vibration isolation, easier grounding, greater corrosion resistance, enhanced compatibility, potential cost savings, and improved aesthetics. When selecting an anchoring method for a switchboard, it's important to carefully consider these benefits in relation to the specific requirements of the installation. It's also recommended to consult with a qualified electrical engineer to ensure that the selected anchoring method is safe, reliable, and compliant with all applicable codes and standards. Furthermore, it is necessary to consider the specific requirements outlined in the project specifications and local electrical codes, such as the National Electrical Code or NEC. These codes provide guidelines for the proper installation and grounding of electrical equipment, including switchboards. For example, NEC Section 384.10 covers the installation of switchboards, including requirements for clearance, access, and working space. NEC Section 250 provides detailed information on grounding and bonding requirements for electrical systems. These requirements are designed to ensure that electrical equipment is properly grounded to protect personnel and equipment from electrical hazards. When using channel iron sills, it is important to ensure that they are properly bonded to the building's grounding system. This can be achieved by connecting the channel iron sills to the grounding electrode conductor with a suitable bonding jumper. The size of the bonding jumper should be determined based on the size of the service entrance conductors, as specified in NEC Table 250.66. In addition to grounding, it is also important to consider the seismic requirements for switchboard installations, especially in areas that are prone to earthquakes. Seismic requirements are designed to ensure that electrical equipment can withstand the forces of an earthquake without collapsing or causing damage. Seismic requirements for switchboard installations are typically based on the International Building Code, or IBC. The IBC specifies the minimum seismic design forces for various types of equipment, including switchboards. When installing a switchboard in a seismic zone, it is important to ensure that the channel iron sills are properly designed and anchored to the floor to resist the seismic forces. This may require the use of special seismic anchors or bracing. In addition to these technical considerations, it is also important to consider the environmental conditions in which the switchboard will be installed. For example, if the switchboard will be installed in a corrosive environment, it is important to use channel iron sills that are made of corrosion-resistant materials. Stainless steel channel iron sills are a good option for corrosive environments. If the switchboard will be installed in a wet location, it is important to ensure that the channel iron sills are properly sealed to prevent water from entering the switchboard. In summary, anchoring switchboard assemblies to channel iron sills offers a number of advantages over traditional concrete bases. However, it is important to carefully consider the specific requirements of the installation, including the electrical codes, seismic requirements, and environmental conditions. By following these guidelines, it is possible to ensure that the switchboard is installed safely and reliably. When evaluating the flexibility of channel iron sills, consider the ease with which they allow for future modifications. Unlike concrete bases, which are permanent structures, channel iron sills can be easily adjusted or relocated to accommodate changes in the electrical system layout. This is particularly beneficial in dynamic environments where equipment upgrades or expansions are anticipated. Regarding the reduced floor load, remember that concrete bases can significantly contribute to the overall weight of a building, especially in multi-story structures. Channel iron sills, being lightweight, minimize the strain on the building's structural support, potentially reducing construction costs and improving structural integrity. In terms of improved access, recognize that the elevated platform created by channel iron sills facilitates easier inspection, maintenance, and repair of the switchboard's components. This accessibility can lead to faster troubleshooting, reduced downtime, and safer working conditions for electrical personnel. When it comes to vibration reduction, appreciate that channel iron sills can dampen vibrations generated by nearby machinery, preventing them from being transmitted to the switchboard. This protection helps to extend the lifespan of sensitive electrical components and ensures the reliable operation of the switchboard. Concerning ease of grounding, bear in mind that channel iron sills provide a direct and convenient pathway for grounding the switchboard, ensuring electrical safety and minimizing the risk of electrical shock. This grounding capability simplifies the installation process and enhances the overall safety of the electrical system. As for corrosion resistance, understand that galvanized or coated channel iron sills offer superior protection against rust and corrosion, especially in humid or harsh environments. This durability ensures the long-term reliability and performance of the switchboard, reducing the need for frequent maintenance or replacements. Considering compatibility with existing infrastructures, note that channel iron sills can be readily integrated into existing building structures such as steel beams or concrete floors, making them ideal for retrofitting electrical systems in older buildings. This adaptability simplifies the installation process and minimizes disruptions to the building's operations. Evaluating cost effectiveness, remember that while concrete bases may seem like a cheaper option initially, channel iron sills can offer long-term cost savings due to their flexibility, durability, and ease of maintenance. A comprehensive cost analysis should consider all factors, including material costs, labor costs, and long-term maintenance expenses to determine the most cost-effective solution. In addition to these advantages, channel iron sills can also enhance the aesthetic appeal of the electrical installation. By elevating the switchboard off the floor, they create a cleaner and more organized appearance, improving the overall visual impression of the electrical room. When selecting channel iron sills, it is crucial to choose a size and material that can adequately support the weight of the switchboard and withstand the forces of vibration and impact. The channel iron should also be properly galvanized or coated to prevent corrosion and ensure long-term durability. It is also essential to ensure that the channel iron sills are properly installed and anchored to the floor, following all applicable codes and standards. This proper installation will prevent the switchboard from shifting or tilting, which could compromise its safety and performance.